sum on how to calculate the integral. So what does the midpoint sum says? It says that if you have an interval a to b and you are dividing it into intervals, say x0, x1 up to xn, where x0 is a and xn is b, then integral a to b of fx dx becomes equal to f of x0 plus x1 by 2 into delta x1, that's a difference, plus f of x1 plus x2 by 2 into delta x2, and so on up to f of xn minus 1 plus xn by 2 into delta xn. So we use the value of f at the midpoint of each subinterval. Use the value of f at the midpoint of each subinterval. So we come to a question now. Approximate integral 0 to 2 x cubed dx by using 4 subintervals of equal width, calculating the left sum, right sum, the midpoint sum, and the actual integral. So let's start with the solution. So your delta x is b minus a by n, so that will be 2 minus 0 by 4, which is half. So we'll divide it into 4 intervals, so 0, half, 1, 3 by 2 and 2. So your left sum would be f of 0 into half plus f of half into half, the width is half. The next interval is f of 1 into the width is half plus f of 3 by 2 into the width is again half. So when you simplify, you will get it as 0. You can substitute fx is x cubed, f of half will be 1 by 8 into half, then f of 1 is 1, so half, f of 3 by 2 is 27 by 8 into half, so this becomes 9 by 4. Now coming to the second part, that is how do you calculate the right sum. So for calculating the right sum, your right endpoints are half, 1, 3 by 2 and 2. You can see here you have half, 1, 3 by 2 and 2. So the right sum will give you f of half into, again the width is half. The next right term is f of 1 into half plus f of 3 by 2 into half plus f of 2 into half. So substituting and simplifying, you will get it as 25 by 4. F of half is, you will get it as 1 by 16 plus 1 by 2 plus 27 by 16 plus 8 by 2. You can calculate the value of fx and check it out. Now, what about the midpoint sum? Coming to the midpoint sum, again you have your intervals here 0, 1, 0, half, 1, 3 by 2 and 2. So your midpoints are 0 plus half by 2, then half plus 1 by 2, 1 plus 3 by 2 by 2, 3 by 2 plus 2 by 2. So that would give you 1 by 4, 3 by 4, 5 by 4 and 7 by 4. So using the midpoint sum, you will get the values as f of 1 by 4 into half, the width is half, then f of 3 by 4 into half, plus f of 5 by 4 into half, plus f of 7 by 4 into half. Now the value of fx is x cubed. So substituting and simplifying, you will get the answer as 31 by 8. Now what about the actual integral? Your actual integral would work out to integral 0 to 2 x cubed dx, that is x raised to 4 by 4 within the limit 0 to 2, and this would be 4. Now I will just introduce the sum using trapezoids, and the sum using trapezoids is denoted by Tn. So basically, if you have a curve like this, you just divide it into small trapezoids here and approximate the sum. When you add all this, you get the sum. This is how you calculate the trapezoidal rule. So Tn using the trapezoidal rule is given by f of x0 plus f of x1 by 2 into h1, where h1 is the width. Then you have f of x1 plus f of x2 by 2 into h2, and so on. You go on up to f of xn minus 1 plus f of xn by 2 into hn. So this is using the trapezoidal rule. So I'll conclude this lesson. So we have learned how to calculate the left sum, right sum, midpoint sum, and the actual sum using integrals, and also the sum using trapezoids. Thank you.